I was asked for just a quick re-explain of the chain rule. So as concisely as I possibly can, I thought it might be worthwhile to compare it to just like what we used to do versus something very similar and why it becomes more complex. So if I take this one for instance and I try to do the derivative, it's a clean power rule, so just the 2 comes out in front. It's just 6x minus 6 based on the power rule. There is no like kind of what's inside because it's just a plain old x. So technically if I wanted to times the derivative of what's inside, well the derivative of x is just 1, so I could do a 6x times a 1. Same thing here. The derivative of this is negative 6, but times the derivative of what's inside would just be times a 1, which would be pretty pointless. But if I put it next to something like this, and now I do the derivative of it, I've got still the chain rule on this, or still the power rule at first on this, so y prime equals 6. When you bring the 2 out in front, leave the 5x plus 1 alone, drop that 2 down to a first power, times the derivative of what's inside, because there's a function within a function. As long as the function within, like you could see this as a quadratic function with a linear in it, technically, but that linear function just has a derivative of 1, so you don't really think about it as the chain rule. This one, the function that's linear within the function is 5x plus 1, which has a derivative of 5. So the derivative of the whole thing following the power rule is just 6 times this to the first times the derivative of that inner function, puts a times 5 on it. And then with this one, you would just do minus 6, right, times the derivative of what's inside, which would be minus 6 times 5, technically. You probably would distribute this one out and not really do it exactly that way, but I just thought I'd kind of show how we go from a simple power rule and it now requires the chain rule when you have a function within the larger function. With this example here, this was just a typical product rule where it's first, f prime is your first, times your derivative of cosine is negative sine. And when you do the derivative of the second, you don't really need to do the derivative of what's inside of that cosine function because it's just a 1. So first times derivative of the second plus second times derivative of the first, which is just 1, and then clean that up. But an equivalent looking function that would need the chain rule would be like a 3x plus 2 times a cosine of, I don't know, 5x. So you do your first times your derivative of the second. Now the derivative of cosine is negative sine, but there's a function within the function, so you'd have to do the derivative of what's inside. So it'd be a negative sine of 5x times the derivative of 5x, which is 5. So first times derivative of the second plus second times derivative of the first, and so on. And then the last one, here's a quotient, so bottom times derivative of the top. So x plus 4 times the derivative of the top is just 1 minus your top times the derivative of the bottom is just 1. You know, there's no function within the function here. Yet, maybe I should have made that one different. What if I did something, again, you'd probably simplify this one out before you just would jump right into it, but I don't know if I can come up with an equivalent here. How could I do a function within a function? Maybe I should have done this. X squared and x squared. And then I'd have bottom times derivative of the top would be 2x minus top times derivative of the bottom would be 2x all over bottom squared. And so I could maybe update that by doing something like 3x plus 1 squared minus 4 over 3x squared plus 4. So you'd have your bottom, which I'm going to do this way, times the derivative of your top. And your derivative of your top would be a power rule on this section. So bring your 2 out in front. of the 3x plus 1 raised to the first power times, now the derivative of what's inside of that innermost function that was squared, the derivative of that is just 3. So that's just the derivative of the first piece of the top, and then luckily the derivative of the second piece of the top is just 0. So bottom times derivative of the top minus da 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 da. So it does get heavier more quickly, but I'm hoping like these jumps side by side kind of show you a little bit more about why we didn't used to need the chain rule, because these were all just plain x's, versus now we've got functions within functions, and so we need to always multiply by the derivative of that innermost function, which I keep saying the derivative of what's inside. So I don't know if that clears anything up. I'm hoping it does. So also let me know if you might be interested in volunteering for just like a trial run of a Google Meets with me, so I can get my feet wet with it and be comfortable with it before totally opening it up. So maybe just like 2 or 3 people, honestly. So send me a message if you're interested in that, helping me out if you do that, and then we could maybe set up a time that works for like 4 of us, just to like give me some practice and see what it would be all about, if you think that that might be helpful for you guys. All right, take care. I'm going to send a video out in a few moments on all the homework questions from today.